So, in our last lecture, we have covered up until the tree address code or the intermediate representation up until the control flow. Now, in this lecture, we will be observing what you can see here, object-oriented programming. Now, I know this is not class for object-oriented programming. However, to be able to understand how this object-oriented programming, which we write in the high-level language, like how does it get translated into, like what happens? So in order to be able to understand that, like how this sequence of coding concept or the high-level instructions get translated, and most importantly, or more particularly, the classes and the objects which we implement in the high-level language, how does or how do those concepts actually get translated into the like machine instructions? Because so far we have seen that the variables which we get to declare, or the arrays, or the record types, or the structure types, at the same time the functions, like they get executed in singular instructions. For example, when we have, let's say, some this sort of operation, so A equals to B plus C minus D plus with, let's say, E is an array, in this manner. What happens when we try to translate this into a tree address code? That happens sequentially, however, with at max 2 operand and 1 parameter, 1 operator. So here in this case, it will be B plus C, and then we will be having, pardon, we have a C minus D. So, okay, it's fine. We can deal with that as well. So after that, we will have T2 equals to, let's say, T1 minus D, and T3 will be equals to, let's say, we will calculate this. Let's say this was declared as integer, like each of the elements was integer. In that scenario, the values will be, in this case, the width, in like width, to be more specific, the width will be 10. It will be width times I. So this is the I values, 10. Okay, yeah, so this is the I value. So 10 times the width. So width will be basically each of the element, which is a 4 bytes. So this is this is calculating the offset value, and then we will have T4, and there we will assign the value in this manner. So T3, this will give us the actual value to be assigned to this T4. That's the tree address equivalent. And finally, we get to add this. We get to add this value. Just a second, let me. Yeah. So we get to add the value. So T5 will be basically T2 plus T4. And finally, we will have A equals to T5. So that's the tree address code equivalent. Now, in such scenario, if let's say we would have something of this format, A equals to B plus function 1, and there we, let's say, pass C as one of the parameter, and function 1, let's say function 1 is defined as int A, and it is going to return, let's say, was the integer type, the text here was integer type, and the return type is less, the return value was, let's say, 5. In that case, what will be the equivalent code? The equivalent code will be, at first, we have this B operand prepared. However, the right operand has not been prepared yet. How do we prepare this? We have to at first declare the parameters. So we declare the parameters as param C. Then we will simply say that call this function 1, and at the same time, write besides this, we have to write how many parameters do we pass. Here in this case, we only had 1 parameter, so we write 1 beside this function 1 call. However, this also returns some value, isn't it? This is going to return this 5. Hence, we will be placing this value to some temporary variable, which is, let's say, in this case, t1. So once we get the value of 5 to this t1, we can perform the operation in the next phase, which is, let's say, t2 equals to b plus t1. And finally, we can assign this t2 value to who? A equals to t2. Okay, so this is the result, the final result we will be getting. Now, see in this case, all this instruction over here got converted to single liner expression, isn't it? Like these are single liner expressions. Now, if that's the scenario, then object-oriented programming is much more complex, what we can see or what we can observe. Because there we have now a new class, let's say T, and then it will have it will have member methods or like, yeah, member functions or member methods. So let's say some int st, and it returns some value, but this will be only accessible once this object has been created, and there will be some variables only assigned, let's say, to this class, and some variables assigned inside the function of the class. So these are the local variables for this function, and these are the global variables inside this class, isn't it? Now, we understand that for this class, or for user data, sorry, not this class. Now, classes are what? Classes are sort of user-defined data types, isn't it? These classes are being made by normal users, the programmers, the developers, or the software engineers, or the future software engineers, which will be you. So in your case, you will be doing what? You will be let me erase this part. So you will be, let's say, declaring or building these classes. So let's say, like, at first, let's say we have what these records, or like when I'm writing a class, let's say, this is what I'm saying, make this class, and I'm defining this class, isn't it? So whenever let's say this is the main function, and inside that main function, I'm creating an object of this class. So class instance, I'm creating an object. So let's say new t. So when I have written this code, that simply means what? Here, the type, I'm saying this t object has the type t of this t class, isn't it? So I'm defining now what? A type. So what happened? Am I audible? Can everyone hear me, or am I like have I been kicked out of the network? Okay, it's breaking. Like now you can hear me properly, or is it still breaking? Like you we like still breaking. Okay, that's weird. Just a second. Let me see. The internet connection here is pretty bad. Now you can hear me properly. Hello. Hello. Okay, then I guess I can, if my voice is not breaking, then I can continue with the class. Now, it seems that I can't